Hello World, I'm Attila. Today I will talk about the science fiction book How Fraud, Bias, Negligence and Hype Undermine the Search for Truth. So this was a book on scientific publishing and how fraudsters and bias create a lot of wrong scientific papers that create wrong results and what is the effect of this on the whole scientific literature. Let's begin. Science is a social thing. You not only run experiments, but you also have to convince others that your results are right, and you have to work with other scientists for a common goal. And talk about like how a scientific process goes and how a typical paper is get published. So first, as a scientist, you read the scientific literature, then you set a research question, and you have a thesis that you want to prove right or wrong, and then you apply for funding. This funding can come from the university, from the government, or from an independent organization or fund like the Melinda and Gates Fund. Then you collect data and analyze that data. Then you write a paper and then you want to publish it. So you find scientific journals to publish your work and you send a copy of your paper to each of them. And if you are lucky, and for the 100th try, the editor of the journal finds that your paper is worth publishing, then the editor will ask two or three scientists who are experts in the field to review your paper, and this is called peer review. And then you make some changes based on that review, or the editor asks you to make some changes, then the paper gets published. Every scientist have these values, and these are called scientific values. And there are three of them. First is universalism. It doesn't matter who comes up with the results, as long as they are sound, as long as they are good. Second is disinterestedness. Scientists have no interest in the outcome. They are in it to advance our understanding of the universe. And the final is communality. Scientists should share knowledge with each other. So this scientific process in theory should be correcting. If you know that there is a mistake in your paper, then you will correct it, and this is good, but that's not how it goes currently. So a big part of this is replication. The replication is when other people from around the world will recreate the experiments that you run, and they check the results to make sure that you didn't commit fraud or there was no mistake in your experiment. So this replication should be part of the process. But a lot of times this replication is not that popular, because hardly anyone runs replication studies, and that's because replicating the success of others is not that interesting. So everyone is in it to invent something new to make the world a better place, not to just replicate things. That's boring. And the other problem is that replication studies don't get published in the scientific journals as often, because it is not as interesting. And even if the result has been corrected, so there was a wrong study, and someone replicated it and came to the right solution, people will still cite the original study, so the one that has been wrong. Then it talks about the problems with the publication system. So the first is image manipulation. If a scientist think that there is a image in their paper and it is not as exciting, then they will try to manipulate it a little bit with Photoshop. And another thing is that in a data collection, there is always measurement and sampling error. And this measurement and sampling error is predictable. It will always be there. And you can detect fraud by a lack of measurement and sampling error. So if someone just came up with the numbers from their heads, then you can detect fraud like this. But this is not perfect, because some people invested more time into doing the fraud than it would have taken them to do the study. But then what did they gain from it? Because they invested more time in it, and they gained control over the results. So they wanted to have a certain outcome of the study, and with fraud they gained that control. We will talk about the incentives of this later. And other fraudsters would exploit the reviewers' desire to publish something interesting. So the reviewers are the 2 or 3 other scientists who are experts in this field. And they also want to find something interesting, because all of them want to make the world a better place. And fraudsters often exploit this desire. The fraudsters often have faith in their theory, and they want to prove it at all costs, and or they just want to be famous or earn a lot of money. And then it talks about this publication bias. And publication bias is when scientists only publish studies with experiments that support their hypothesis. So if you have a hypothesis and you run an experiment and it turns out that your hypothesis was wrong, you won't publish it. Because with these negative effects, they are not likely to get published in scientific journals. Because we want to hear about positive things. And if a theory is not correct, then nobody is interested in it. And if you want to have a certain outcome of study, you can measure a data set 1,000 ways. So, for example, there are these outliers, that you can say to them that they are measurement errors, or you can say something different to them. So you can analyze a data set as you want to have the results. And money is also a big incentive. For example, a pharmaceutical company might compare its product not to the second best product on the market, but to a useless drug to make the results look better. Because every one of them want to write on its product that this is 50% better than all the other products. And so money is a big incentive. And other incentive could be that scientists want their study to be successful because they want to contribute to a big cause like climate change. So we know that climate change is very bad, and it will be an even bigger problem in the future. And these poor scientists also want to contribute and solve the climate change, and they do that by making fraud, because they want to be important. be important in this process to solve climate change. So these biases are all part of a human nature, and it is not easy to correct them. And there are not just biases, but also negligence. So numerical errors make a big part of these mistakes in the papers too. So as a kid, I often thought that like these big scientists who are very famous would never make numerical errors, but it turns out that they do make numerical errors. But making errors is a human mistake, so we can't blame them very much. But if they don't focus on it, or if they just don't correct numerical error because they want to have a certain outcome, then that's a problem. Hype and media can also exaggerate the results. So there was one number that I remember it very much. It said that when a study is translated by the media to a different language, then on average they 50x'd the results. So of course everyone would like to have in the media that like how outstandingly big effect of a study there is, and because of that they will often exaggerate the results. But science is complicated. Even the best authors have a difficult time making sense of these contrarian studies that have different outcomes compared to each other. Which author do you trust more? And all of this is a big damage to the scientific literature. So if there is a wrong study that is not spotted, and it will get to the media, and TED Talks are written about them and the best-selling books, then other studies will cite that study, and they will also publish things based on them, and like then third studies will also cite not the original but like the second study. And with this, there are these enormous systems when they can build a whole house or system on a study that is wrong. So that's a very big problem. It talked about like a big replication crisis was in physiology some years ago, when they had to replicate a ton of physiology studies because most of them turned out to be wrong. And the problem is that these frauds are just the ones that we know about. We can, if we don't replicate these studies and if we don't recreate them, then we can build our entire human understanding based on that. And it can have very real world consequences as well. So a doctor might treat his patient in a certain way because he read a paper. So, and if that treatment is not good, then it can cost a human life. So this is a very important problem. I can't emphasize it enough. In the last part, it talked about solutions. What are the possible solutions after this whole huge mess? So researchers are developing algorithms that can spot false data or image manipulation or duplication. So that's a huge thing. I would imagine that an AI would be able to spot measurement errors or these numerical errors in a study, or the lack of measurement errors in a study. And I think that's a huge thing, but of course we can't rely only on technological solutions. We should also make it easier to publish replications and null results. The null results are these negative results. because currently no one is interested in publishing replications and negative results. And the problem is that if you publish papers with new interesting studies, in the future you will get more funding, because from the government or universities, the scientists get funding who have a lot of publication and who have a lot of interesting publications. And if you only publish replications and new results, often they don't get published. As a result of that, you don't get the funding later. So we should make it easier to publish replications and null results. And before you make the study, before you collect data, we should publish a plan of how you want to analyze data and your whole research question or your whole thesis ahead of the data collection. And that would make it easier to see the scientists who, after the data collection, change their thesis or change their research question based on the outcome of that data collection. And if you can reach, if you have access to the way they wanted to analyze the data ahead of the data collection, then it will be difficult for them to analyze their data in a certain way in order to have their outcome. And as a whole, we should build a system in which scientists are rewarded for their contributions rather than for merely having their name on a paper. So currently researchers get funding if they publish a lot and if they publish interesting things. And rather than that, we should build a credit system, for example, when you can get credit if you replicate studies or if you detect fraud. So we have a problem in the system, and as I understood it, there is this huge mess in this paper publishing industry. And if you happen to be a scientist, then you should read this book, because in the end there is an appendix on how you should read a paper and to prove it, if it's wrong or not. So this book was very interesting. Of course, probably I'm not the target audience, but it was interesting nevertheless. So if you want to recommend me some books, then you can reach me in the YouTube comment sections and also on Twitter. Subscribe to my YouTube channel and follow my podcast if you are interested in stuff like this. All things are in the description, you should check it out. Thank you for coming in, bye bye.